Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Dual Nature of Radiation and Matter came in a year NEET 2024. In this question we will learn about the de Broglie hypothesis. You know very well light is a wave, but in some phenomena like a photoelectric effect it behaves as a particle also. Similarly, if we talk about the particles like electron, proton, neutron or any other particle, they will behave as a wave also. But if the mass of the particle is very small like a proton, electron and all that, then that wavelength will be observable. Okay, so let's go through the question. So here you can see the question is an electron and an alpha particle are accelerated by the same potential difference. Now this is given. Now let lambda e and lambda alpha denote the de Broglie wavelength of the electron and the alpha particle respectively. Then here four options are given. So in the question they are talking about only electron and alpha particle, but I will compare with proton and neutron also. One general kind of question I will make for this. Okay. So remember that here if we talk about here the wavelength is given by in a de Broglie hypothesis H equal to root 2 mk. K is the kinetic energy and that kinetic energy we can write here Q into V. Okay, remember that. Now if we talk about here in the question what they are telling, in the question they are telling the potential difference is same potential difference. For this specific case only we are going to solve it. Okay, so what will happen that here as V is constant and this 2 is also constant and H also constant. So I can tell this lambda is directly proportional to 1 by root m into q. Now because other things and all constant here, is it? Now after that see, let me put here in a box. Now I will write here one by one. Now so see here, if I write for the electron, what will happen that here, see I am just writing here, from here also I can write here, see here root 2m, root 2m and see here this 2 and mass electron into charge of the electron, how much here E, and potential anyhow V only, is it? That we can tell for the electron. Now similarly if we write for the proton, now I will take proton, neutron, alpha particle all. So in case of proton what will happen that here H by root 2, mass will be, let's take here mass of proton MP, charge will be E, potential will be V. Okay, we have written for proton. After that if we write for the deuteron what will be there H by root 2. Now I am using this formula here. Now if any other kind of formula is there, in that you have to just take the ratio there, this also you can use it, but I will just use here the actual formula. So what will happen that here 2, and here for the deuteron what will happen, the mass will be the twice of the mass of the proton for the deuteron and the charge will be as it is E into V. Okay, and if I talk about here the alpha particle, so see here H by this is root, mass will be 4m and the charge will be 2e into V. Now because at all the points potential is same. Now this thing we have written. Now if we talk about here, see for the proton. So for the proton what I am writing here, let's take here anyhow, this is the lambda proton only, correct? This I have taken. So here what will happen that here you can see very well, if you will compare this one and this one, 2 extra will be appearing here. So that I can write here lambda p by root 2, correct? What is there? This lambda deuteron we can write here lambda p by root 2, is it? Similarly if you talk about here this lambda proton, because here you see here this 1 extra 2 came, but here what will happen that here, kindly see here this 4 will come and this 2 will also extra will be there now. So root 8 and this root 8 will become here 2 root 2. Okay, so if you talk about here we have seen lambda proton, lambda deuteron and lambda alpha particle also, is it? You know very well here lambda proton is definitely greater than the lambda deuteron and lambda deuteron is definitely greater than lambda alpha. But if we talk about here lambda electron and lambda proton, which one is greater? Okay, so here you remember that one thing here, the mass of the electron is used to be very small compared to the mass of the proton. That means if we have to compare between lambda electron and lambda proton, what will be there? The lambda electron will be greater now because mass is small. So overall if I write here, see here this is the lambda electron first, then after that what will come here lambda proton, and here lambda deuteron. You can see now by root 2 is there, root 2 value is 1.414 more than 1. Okay, so here what will happen that here now the lambda proton will be greater than lambda deuteron. Here also you can see in the denominator 2 root 2 is there. Now that means anyhow this lambda deuteron is greater than lambda alpha, is it? So this relation you have to remember that here, just little bit you have to think and you will get it here, is it? So just let me write here, see, this is the no? So kindly see very well, little bit you have to just think, little bit mathematically you can get it very well. So if you will see here which option is anyhow the best option is applicable here, the correct option is here, option A is the answer, is it students? So I hope so this video of dual nature of radiation and matter in which we have used de-Broglie hypothesis is very clear to you. Keep studying, keep growing.